Hey, welcome back. Here we are. We're going to finish up the slides from today. There's just a couple of techniques to know, and the main thing is connecting a triangle with a circle. And I want to show you this diagram. This is really my favorite diagram. Here's what it looks like in quadrant 1, but it does continue into the other 3 quadrants. And we're connecting, there's a triangle and there's a circle. So if we connect those, then we have a lot of power to solve trigonometric functions. So where's the triangle? That's easy to see. Here's the triangle right there. And that's a right triangle. And what we're looking at is we are looking at a point on the unit circle, and the point is right here, and the coordinates are x comma y, and x is the cosine of the angle and y is the sine of the angle. And with that, these are some equations that are worth writing down several times. Cosine, and we could put the parentheses here because it really is a function. Often we leave those off. And y equals sine of t. Sine is also a function. T is the input variable, y is the output, y is the y-coordinate. So the y-coordinate, it's the height of that point above the x-axis. So this distance is y, and you can see why this is labeled as sine of t. And the x-coordinate, that's the horizontal displacement. This is x, and you can see why that's labeled cosine of t. And the angle t is measured in the standard direction, positive, in the positive direction from the positive x-axis towards the terminal ray, so that's counterclockwise. And here the radius is 1. So there's the triangle, and notice it is a right triangle. And the circle is, it's a unit circle. What does that mean? That means that the radius is 1, and the center is the origin, so the equation is x squared plus y squared equals 1, and that's actually the equation of a circle and also the equation of a triangle because of Pythagoras. And it's sometimes called the Pythagorean Identity, because if you replace x by cosine, we put the square over here, and y squared is sine of t squared, we put the square over here, that equals 1. That cosine squared plus sine squared equals 1 because we have that triangle. So it's both the equation of a circle and a triangle. Now we have that, and so I think it's time to move on and let's solve some problems. So next slide. Here we're told the cosine of the angle is 24/25, and t is in the 4th quadrant. The goal is to find the sine of the angle. So I want to share a powerful problem-solving technique. It doesn't always work. It's called a heuristic. If you're stuck and you don't know how to start, then here's one of my favorite heuristics, and that's just to draw a picture. Let's see if we can picture what this is about. And here's the picture. Let's draw the x-axis, the y-axis, and here is a circle right there, a perfect circle, and we are looking at the 4th quadrant. Here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So this has something to do with a point in the 4th quadrant, and here is a terminal ray, and that means that the angle that we're interested in terminates over there in the 4th quadrant, and let's call that the angle t. And that means that the x-coordinate is going to be positive and the y-coordinate is going to be negative, but we may as well label this point, it's both x comma y, and it's also cosine of t, sine of t. And you don't have to do this, but it's always helpful to write in the parentheses because sine and cosine really are functions. And so we're given that the cosine of t is 24 over 25. So that means x equals 24 over 25. And we want to find sine of t. So that really means find y, because y and sine of t are the same. And the key here is that the point is on the circle, so the x squared plus the y squared equals 1. And that means 24 over 25 quantity squared plus y squared equals 1. And that's enough to solve for y. You can see that there's going to be a positive solution and a negative solution. We want the negative solution because we're in the fourth quadrant. Okay, so how do we solve this? It's not so bad. It's not bad at all, but you could get into some trouble doing arithmetic because we have to square 24 and square 25. But I'm going to avoid that by doing this. I know that y squared is 1 minus 24 over 25 squared. And I'm going to use some algebra to avoid doing arithmetic, because I know that this is going to be the same as 25 over 25 squared minus 24 over 25 squared. And right there I have a difference of 2 squares, and so I can factor that. That's 25 over 25 plus 24 over 25 times 25 over 25 minus 24 over 25. Do you see the difference of 2 squares? Well, that makes it really easy, because this one is 49 over 25, and this one is 1 over 25. So y squared is that, and both of those are perfect squares. You know that 25, well, we have a 25 times 25, so the denominator is 25 squared, and 49 is actually 7 squared, and 1 is just 1, so this is 7 over 25 quantity squared. And so this means that y is plus or minus 7 over 25, but we know that we want the negative one, so y is negative 7 over 25, and that means that we have our answer. Sine of this angle is negative 7 over 25, and let's put a box around that. And you can see that that makes sense. The coordinates of that point are 24, 25, that's close to 1, and negative 7 over 25. And sine of t, that is the y coordinate. So let's move on. Here are some special angles. Let me remind you, special angles. And there's actually 5 points along the circle in the first quadrant that we want to know. In terms of the radian measure, 0, pi over 6, pi over 4, pi over 3, and pi over 2. And in terms of degrees, that's 90 degrees, 60 degrees, 45 degrees, 30 degrees, and 0 degrees. And those are 5 special angles. If you know those, then you know all of the special angles all around the circle. And I'll just point out where those are. There's the eighths. Those are multiples of 45 degrees, or multiples of pi over 4. And then there's the multiples of pi over 6, which bunch up like this. And those are the special angles. But if you know these 5 special angles, you basically know everything, because those act as very good reference angles. Those are 5 special reference angles. So let's start with pi over 4. And for this, I want to draw a line. Let's take it through here. Oh, I shouldn't have done yellow. That's a bit too light. Let's try orange. And the equation of this line is y equals x, because 45 degrees means that here's 45 degrees. That means that the slope of this line is 1. And there's a square here. There's a hidden square that I want to show you. And that starts here, goes up, over, and down. There's a square, and we're really just taking that square and we're breaking it in half. But anyway, since y equals x and x squared plus y squared equals 1, we have a system of two equations and two unknowns, and we can solve that just by the standard technique of eliminating a variable. This means x squared plus x squared equals 1 because y is the same as x, or 2x squared equals 1, and x squared is 1/2. So x is going to be a positive number. It'll be the square root of 1/2, which is the square root of 1 over the square root of 2, or 1 over the square root of 2. But usually we rationalize the denominator. We'll multiply by 1 in this sense, and that lets us express this as root 2 over 2. So x is root 2 over 2, and y is the same, so y is also root 2 over 2. And this means that this point, this point has coordinates root 2 over 2 and root 2 over 2. That's cosine of t. T is pi over 4, and sine of pi over 4. So we can just fill this in. Sine of pi over 4 and cosine of pi over 4 are both root 2 over 2. And let's just put a box around that. That's one special angle, and I like to think of it as related to a square. Let's do pi over 6. That's another one. And just as a reminder, it goes here. This is an angle of pi over 6, and so we're looking at this special point right there. You can think of 30 degrees, and we want to know what's the cosine of pi over 6 and what's the sine of pi over 6. Always remember that cosine is the x-coordinate and y is the sine of pi over 6. So here's a trick. I really love this one. That if you go in reverse negative 30 degrees or 30 degrees counterclockwise, then you end up with a terminal ray that's a reflection. And so here's 30 degrees. That means that this whole thing is 60 degrees. And if we connect these points, we actually have an equilateral triangle. The radius is 1, which means that this whole length is 1, but that is 2 times the y-coordinate. You can see that there's this far is y, and then this far is y. So 2y is 1. That means that y is 1/2, and that means that we have just discovered that the sine of pi over 6 is 1/2. That is worth putting a box around. How do we figure out x? Well, remember that this is all on the unit circle, so we could go back to the equation x squared plus y squared equals 1. We know that y is 1/2, and so this is enough to solve for x. Let me change 1 to 2 over 2 squared, because I'm going to be working with fractions. That means that x squared is x squared plus 1/4 is 4/4, or x squared is equal to 3 over 4. And that means that x is the square root of 3 over the square root of 4, which is 2. And this means that we've just found the cosine of pi over 6 to be positive root 3 over 2. I took the positive root because I know that I'm looking at quadrant 1. Pi over 6 is in quadrant 1, so both the x and the y coordinate, both the cosine and sine, are positive. And that's pi over 6. Let's move on and look at pi over 3. So pi over 3, it's somewhere like here. And here's pi over 3. That means that this angle, pi over 3, that's 60 degrees. And we actually have another triangle. If I connect these 3 points, let's see if I can make it an equilateral triangle. You can see that the radius is 1, so it's an isosceles triangle. That means that these two angles are equal. The third angle is 60 degrees. That means that they all have to be 60 degrees. And that means that that means, let's see, let's draw on this line. Here's the point xy, and you can see that x is this horizontal, it's the base of the triangle, but by symmetry, x is that one as well, so that means that 2x equals 1, or x equals 1/2. And this is enough to know that we've just computed the cosine of pi over 3 is 1/2. Let's put a box around that. And now we want to find y. We are in quadrant 1, so y is positive. And we are in a circle, this unit circle, so x squared plus y squared equals 1 squared. And x is 1/2 squared plus y squared equals 1. And we've actually done this before. Y squared is 3 over 4, so y is root 3 over root 4. And this means that the sine of pi over 3 is root 3 over 2. And let's put a box around that. So pi over 4, we're looking at a square. And for pi over 6 and pi over 3, finding those related to looking at an equilateral triangle. So root 3 over 2 is the height. Let's just fill in what we know. I do want to make a picture of that first quadrant of the unit circle. Here is the unit circle. It continues around, and the 5 special points that we wanted were 0. Here is pi over 4 radians. Here's pi over 2 radians. And then at 60 degrees, that's pi over 3 radians. And at 30 degrees, pi over 6 radians. And let's just remember those 5 points were, let's see, well, 1, 0 and 0, 1. We didn't compute those, but we know those. And at pi over 6, it was root 3 over 2, comma 1/2. For pi over 4, it was root 2 over 2, root 2 over 2. And for pi over 3, it's 1/2 root 3 over 2. And just remember, x is the cosine, y is the sine. So just reading off, we can just read it off. The x coordinates are 1, root 3 over 2, root 2 over 2, 1/2, and 0. And the y coordinates are the same numbers but in reverse order because there's some symmetry here. And just for fun, I wanted to show you a pattern. the y-coordinate for pi over 4 is root 2 over 2, that's the sine. And for pi over 3, it'll be root 3 over 2. And for pi over 6, it's 1/2. But we could write that as root 1 over 2. And then for pi over 2, the y-coordinate is 1. That's the same as 2 over 2. And so we could actually write that as root 4 over 2. And then, of course, for 0, the y-coordinate is 0. And that's the same as 0 over 2. We could make that root 0 over 2. And so there's a really fun pattern. Root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, and root 4 over 2. And I just used that as a mnemonic. I think that's kind of fun. So that's it. Let's finish up there on Google Classroom, and see you in class on Thursday. Thanks.